Hello my dear NSEJS aspirants, I hope your preparation is going well, and if you are really preparing seriously for your NSEJS 2025 or NSEJS 2026 and if you are looking for a support, then contact to the mobile numbers given on the screen so that our team will respond and will be connected to the batch that we are running for NSEJS. Okay, now let us discuss the PYQs of NSEJS 2023 here. So look at this, the first question here, a glass bulb of 1 liter capacity contains 4 grams of methane. The bulb is so as to burst out if the pressure exceeds just 10 atm pressure. Then the temperature at which the pressure of gas reaches the bursting point close to. So we need to find the temperature where the bulb will burst. Okay, this is very easy. So we can use ideal gas equation PV equals to nRT. Okay, so using this, see they have mentioned the capacity of pressure, the maximum pressure can be 10 atm they are saying, and the maximum volume is mentioned as 1 liter. Yes, so this data is given, and you know number of moles you can calculate from the given mass. Okay, now the only thing we don't know is temperature. That is what we need to find here. So temperature will be PV by NR. That's it now. So what is the P mentioned here? That is 10 atm. So 10 atm multiplied with the volume mentioned as 1 liter. So 1 liter I am taking here, and number of moles given as 4 grams is given now. So number of moles is what? Given weight by its molar mass. What is the given weight we have? 4 grams. What is the molar mass of methane? We know it is 16 gram per mole right now. So that you will get 0.25 mole right now, or you can take 1 by 4 moles. So you can, here I am writing 0.25 mole. Okay, multiplied with what is the R value? We can take, we want R value in terms of liter atm, as we have the numerator as liter atm. So you can use this data which is given. So R is equals to 0.082 liter atm Kelvin inverse mole inverse right now. Yeah, so just remove all the units that can be possible here. So liter atm can be removed, and mole inverse. So your answer is in terms of kelvins right now. Temperature will be in terms of Kelvin here. Okay, so now this can be, I can write this 0.25 as 1 by 4, that is nothing but 40 by 0.082 Kelvin right now, temperature in terms of Kelvin. So by simplifying this, you are going to get around 487 Kelvin. So here we have 487 Kelvin here. So that will be our answer. Option B will be your answer for this particular question. Hope this is clear. Right. Let us move forward with few more questions. See, yeah. So if you want, you can just take a screenshot of these. Okay, and let's move forward with one more question here. The bond which will break in the first step when the following compound react with H3O plus. Okay, so whenever you treat with H3O plus to this compound, so which bond will be breaking first? This is the question asking. Very simple. So look at here. So whenever you add H plus to this one, whenever you add H plus to this given compound, acetic acid is given, the non-bonding electrons here, the non-bonding electrons present on this oxygen, and this oxygen will first participate. So here you can see we have pi electrons as well as the non-bonding electrons here now. So these electrons will take the proton first. Okay, therefore making this oxygen more electrophilic after accepting the proton. Therefore the bond here, the pi bond which is weaker than the sigma bond, will break first. So which is breaking first? This bond B is breaking first. So what is your answer? Option B, bond B is breaking first during this addition of H3O plus to the given carboxylic acid. Hope this is also clear. Right. Okay, so let us move forward with few more questions. Yeah, look at this. We have again one more question for NSEJS 2023. The element X has two natural isotopes, that is X, 5, 10. So 10 represents mass number of that element X, 5 represents atomic number of element X. Okay, so now having mass, exact mass as 10.013 units. Okay, and another one as atomic number 5. Okay, same atomic number isotope means, yeah, but mass number are different. Okay, so exact atomic mass is given as 11.009 units. Okay, so now they are asking the relative abundances, and they are saying relative abundances of these two isotopes in the nature is given as 19.8 for the first one, and for the second one is 80.2. okay, this is the percentage of abundance as they mentioned here. So now what is the relative abundance given here? 19.8 and 80.2. okay, after this what you need to do? So percentage abundance is nothing but summation of, you just take this summation of or average atomic mass is equals to summation of percentage abundance multiplied with its atomic weight, okay, by 100 you do. So for example here, just look at this, two isotopes are possible now. So what is the percentage abundance for first one? 19.8. so 19.8 into its atomic weight is how much they mentioned? So 10.013, okay, plus, and second one is having 82 percentage abundance, 80.2%, okay, multiplied with its atomic number as atomic mass as 11.009 units, and total percentage abundance will be 100 now. So 19.8 plus 80.2 is 100. So I am taking here in the denominator. So you are going to get average atomic mass. So will be like this. Okay. So this will be 198 into 10 around. So I am just taking it as 10, so that will get at least the nearest option here. So yeah. So it will be 198, let me take this and we will check, and this will be how much? 80.2 multiplied with 11. So it will be 208, so that 2288, okay. So one decimal, so 882.2 by 100 you take. So how much it is? So how much it will be? 100 you take here, okay. So just add 198, so 20181, okay. So 10 here, so 1000. So like this we have, so take here 1080 we got, so 1080 we have by 100 we have right now. So just you will get answer around 10.8. okay. So just check the options, do we have any option? Yes. So 10.802, so which is greater than the 10.8 now, so we have option D as greater than 10.8 right now. So we can go with option D as our answer, which is 10.812. So your option D will be perfect answer for this particular question, right? Yeah. So this will be your answer, okay. So let us move forward with few more questions here. So look at this, the pH of 10 power minus 10 molar HCl, very easy. So pH formula is what? Minus log concentration of H plus ion, right now that should be normalities, okay. Since HCl is given, it is a mono basic acid, so molarity and normality are equal for this particular acid, okay, as its N factor is same here. Okay, its N factor is same here, so normality and molarity will be equal. Okay, so therefore here if you directly substitute this value, what you are going to get? So pH, if you directly substitute the given value, so your answer will be minus log concentration of 10 power minus 8 means you are going to get 8. pH 8 means that will be acidic or basic. See, this indicates the solution is basic right now. So this reaction temperature is not mentioned now, take it at 25 degrees Celsius. See, if at 25 degrees Celsius, if pH 7, if we say this is neutral, we are saying at 25 degrees, below this we are saying acidic, and above this we are saying basic right now. So if you directly blindly take this value and if you put here, you are going to get 8, which is falling in the basic region, which means HCl is a basic. If you do like this, it means whatever the concept you have learned here, that is incorrect. So what is the exact way here to answer this? See, pH means concentration of minus log concentration of H plus we are taking now. So that H plus ion should be taken, from acid as well as water, H plus ion from water. Okay, so at 25 degrees Celsius, the H plus ion concentration from water will be considered as 10 power minus 7 molar, and from acid is given as 10 power minus 8, right now. So total H plus ion concentration, I can say total H plus ion concentration is equals to 10 power minus 7 plus 10 power minus 8, that is nothing but I can write it as 1, I can write it as how much, 1.1 into 10 power minus 7 I am writing. Yes, we can write it now. Yes. So if you write it like this, we got concentration of H plus ion like this. So pH, now you substitute that value, you will get exact value. Log minus log concentration of H plus ion, that is 1.1 into 10 power minus 7. Okay. So this is nothing but pH equals to, so apply log A into B formula, right. So log A plus log B formula will get by substituting that. So yeah. So your answer will be something like this, 7 minus log 1.1. So 7 minus, you are removing 7 minus log 1.1, that is nothing but less than 7, na? You are doing pH 7 minus something, it means lesser than 7. So where do we have lesser than 7? Yeah, so pH will be less than 7, your option B will be perfect answer. See, look at here, they mentioned option C as 8, that is the blend, like blender mistake most of the students will do by simply substituting there if they don't know, and you are going with a wrong option of C. Okay, that is purely incorrect. So go with option B, which is perfect answer here we got through this. Okay, hope this is clear. Yes, if it is clear, just click on the like button, and if you are new to the channel, just click on the subscribe button also. Okay, yeah. Next, let us move forward with few more questions. Yeah, look at these. Look at these. So look at this question here, the total number of lone pair electrons on I3 minus. So how can you calculate this? I3 minus, just hold on. So I3 minus means how you will do this. See, I3 minus. So what is the central atom? You can say iodine itself is a central atom and iodine itself is a surrounding atoms. Totally you can write it like this. So iodine central atom now, halogen 17th group element now. So how many valency electrons? If it is 17th group element, just remember 7 valency electrons will be there. If it is 16th group, 6 valency electrons. So now take 17th group iodine, so 7 valency electrons, and minus charge is there now, you add that electron also. Totally how many electrons you will get? 7 plus 1, 8 electrons. Now put 8 dots like this. Okay, so how many over? 1, 2, 3, 4, 5, 6, 7, 8. Okay, after that, so now see how many surrounding atoms are there? 2. Okay, so one iodine and second iodine. Okay, remaining, this is one set of lone pair and another set of lone pair and another set of lone pair. So total number of lone pair electrons on central atom is how many? So iodine with 2 surrounding atoms and 3 set of lone pairs. Okay, this sigma bond, this is also sigma bond. If they ask like this, the total number of lone pair electrons on central iodine atom, your answer should be 3. Okay, they are asking the total number of lone pairs of electrons in I3 minus, means consider whole molecule and answer the question. Okay, so now in order to do that, just look at here. See, totally you have 2 sigma bonds plus 3 lone pairs. So total 3 plus 2, 5, right? So 5 means you are going to get sp3 hybridization. It means it will be having trigonal bipyramidal geometry. So what do we mean by trigonal bipyramidal geometry? You write the central atom like this and put 5 bonds like this. Okay, 3 over, and the next one is here and here. Okay, and you know this white color line, whichever you are seeing, this one and this one and this one, these bonds are called equatorial bonds. You place the lone pair electrons in these equatorial positions like this. Okay, because they are separated with 120 degree angle, which is maximum separation in this particular structure. Okay, so lone pair should be kept in the maximum separated angle because they will if they are very close, they experiences maximum repulsion. So to minimize the repulsions, we are placing them with maximum separation. Okay, whereas these yellow color lines are called axial bonds, where you need to place these atoms, whatever the atoms given here. Okay, like this. Okay, so now we know what we know, the halogen contains 7 valency electrons, no? So these are also halogens, only 1 electron of that particular atoms are involved, remaining 6 will be remained non participated, no? So not participated, so there will be non bonding electrons. So put 6 dots around this like this, yeah, here also, yeah, it means central atom also contains 3 lone pair electrons, surrounding atoms also contain 3 lone pair here and here, okay. So total 3 plus 3 plus 3, so 9 lone pairs are there, okay, pairs I am saying, so 9 lone pairs are there. So your option D will be perfect answer for this particular question. Hope this is also clear, right now? Yes, if this is clear, see, I am not just giving the answer directly, I just want to cover the concepts involved here also, okay. Yeah, I hope you are really clear with the concept, and yeah, if there is any doubt, feel free to ask me in the comment box, okay. Yeah, let us move forward with few more questions. Yeah, so the maximum number of CH3 groups which may be present in an alkane given with the formula C11H24 is close to, guys, you know, there is a similar kind of question in NSEC 2023 paper. So this is NSEJS 2023, right? So this is JS junior, that is for 11th and 12th, that is NSEC we have now. So in that similar kind of question I have found, okay. Yeah, if you are really preparing for NSEJS, NSEC, see, continue your preparation for the next Olympiad also. If you are at 10th, 9th, 10th, you can also aim for your 11th and 12th preparation also, NSEC also you can aim, okay, you can able to do that, okay. So look at this, with this knowledge you can extend little more and you can perform better in the future also. Yes, so we have C11H24 we have, so it means it is an alkane, they are only saying it is an alkane. First of all, find whether alkene or alkyne by looking at the formula. Generalized formulas are there now. What is generalized formula of alkane? CnH2n plus 2, always find like this, okay. So it is satisfying this formula, so I can say this a given compound is alkane as they also mentioned here, no need of find, okay. Yeah, if they won't mention, try to find this using this formula and CnH2n, this alkane, this general formula, so that you will get what it is exactly. Now we know it is an alkane, so now try to construct a formula, I mean structure having the maximum number of methyl groups. So I am placing 4, 5 like this I have placed, 1, 2, 3, 4, 5 I have placed. Now let us see, I am placing one methyl group here and one more methyl group here, and then next one methyl group here and another one also here, 1, 2, 3, 4, 5 over, 6, 7, 8, 9 over, 10, 11 over, okay. See, just count 1, 2, 3, 4, 5, 6, 7, 8 over, okay, 9, 10, 11. All 11 carbons are included, which is having 3 plus 3, 6, 7, 8. So how many methyl groups we got? A maximum number of 8 methyl groups we got in this particular molecule right now. So we have maximum number 8 in the options also, so that will be your perfect answer. You just try, is there any other possibility to arrange them? No, right? Because see, the carbons can be placed with the hydrogens, maximum of 2 hydrogens are possible after forming this chain, the two sides chain with the carbons. So that 2 hydrogens are replaced by 2 methyl groups, like that, this one, this one, this one. So over, so 6, 7, 8. So these are the possible number of methyl groups, that's it, okay. So option C will be your perfect answer for this particular question, right? Yeah. Let us move forward with one more question here. The compound which is used to purify air in the space shuttles, submarines, breathing mask is, okay, very simple. See, potassium superoxide, KO2 will be used here. So KO2 will be absorbs what? Carbon dioxide, okay, and forms and it releases CO, it will absorb carbon dioxide, CO2, and releases oxygen. So therefore which is used here for purification? KO2 will be used here. So option 2 will be a perfect answer for this particular question, okay. Yes guys, and here, yeah, so look at this, H2 reacts faster with chlorine at 13 times faster rate than D2, because, so why H2 is react more readily with D2, they are asking. with the chlorine. When we react with chlorine, H2 is having more reactivity than chlorine, then D2, deuterium. Okay, why it is so? So because the bond energy of HH bond energy is relatively less when I compare with the DD bond. Okay, so HH bond energy is lesser, na, it is easy to break, therefore it will combine very easily. I mean, it will involve in the reaction very easily when I compare with the DD. Okay, so this is also, I can say, isotopic effect. During the chemical reactions, we will be using this, and we can able to find which is faster rate, which is slower rate also. So what I am saying, H2 has lower, see, in H2 HH bond energy is higher. No, in H2 has lower activation energy because HH bond energy is lower than DD bond energy. So option C will be a perfect answer for this question, right now? Yes. If everything is clear till now, you just click on the like button, and also you can share with your friends, those who are preparing for NSEJS or NSEC or any such Olympiads like physics, chemistry, mathematics. Okay, and yeah. So guys, try this question. This is for you as a homework. Yeah, so try this question. This is also NSEJS 2023 question only, and I just wanted to show you few more questions also. Yeah, look at this. All these are NSEJS questions only. So just try to solve these questions. If you are really facing difficulty to answer them, just watch my previous sessions that I have made on this NSEJS. Okay, so just go through the playlist of NSEJS in this channel and watch all the videos. Okay, you will definitely get some idea on what kind of questions they are asking in the exam. Okay, yes, thank you for watching. Stay connected with this NEET World channel. Thank you.